Welcome to the Explainer. Today, we're going to tackle a huge challenge for any programmer: how to give your application a memory. Let's get right into it.
Okay, let's start with the core problem. Think about it for a second. Every single variable, every calculation, all the data you create inside a program, it just vanishes the second that program stops running. It's like its brain gets wiped clean every single time. And to build anything useful, anything from a simple to-do list to a complex data tool, you have to solve this. You've got to give your program a memory.
So here's our game plan. We're going to start with that core problem of data amnesia. Then look at our first solution using plain text files. After that, we'll see why that's not always enough and tackle structured data with the CSV module. And finally, we'll get a professional upgrade using dictionaries. So where do we even begin? Well, we start with the simplest, most direct solution there is, just teaching our program to write things down in a plain old text file.
The magic for all of this starts with one single powerful function: open. You can think of it like your program picking up a pen and a notebook. All you have to do is tell it which notebook to use, that's the file path, and what you're planning to do with it.
And that second part, what you plan on doing, that's called the mode. It's super important. Are you just planning on reading what's already there? That's R. Do you want to wipe the whole thing clean and start over from scratch? Then you'll use W for write. Or maybe you just want to add a new thought to the very end of the file. That's A for append. Getting this right is the first critical step. Okay, now listen up, because this is the single most important best practice for handling files in Python. You need to use the with statement. Always. It creates something called a context manager, but you can just think of it as a safety net. It absolutely guarantees that your file gets closed properly, no matter what happens, even if your program hits an error and crashes. This isn't just a suggestion, it's the professional standard. All right, so we've successfully written our notes down. But memory is a two-way street, right? It's no good if we can't get that information back. So now we need to read it. So Python gives us a couple of main tools for this. You can use .read, which, well, it does what it says. It just slurps up the entire file into one giant string, kind of like unrolling a huge scroll. Or you could use .readlines, which is a little neater. It gives you back a Python list where every single item in the list is one line from your file. But honestly, the most elegant, most memory-efficient way, especially if you're dealing with a gigantic file, is to not read it all at once. Instead, you can just loop directly over the file object itself. This is amazing because it processes the file just one line at a time, which is super fast and barely uses any resources. Oh, and please, don't forget .strip. It's your best friend for cleaning up those invisible new line characters at the end of every line. Okay, so far so good. But now we've hit our first major roadblock. Writing simple lines of text is totally fine for, say, a diary or some notes. But it completely falls apart the moment your data has any kind of structure, like the rows and columns you'd find in a spreadsheet. And this is a real problem. Imagine you have a list of users, and for each user, you have a name, an email, and a status. Just trying to write that to a file becomes a nightmare fast. It's unreadable, it's clumsy, and it's just begging for errors. We need a better system. And this is where Python really shines, because it gives us a beautiful built-in solution for this exact problem. It's a specialized tool designed to perfectly handle this kind of tabular data, the CSV module. So CSV stands for comma separated values, and you can basically think of it as the universal language for data. It's a simple text format that pretty much any program that handles data, Excel, Google Sheets, databases, they all understand it perfectly. It's the perfect choice for storing structured information. And the process is just wonderfully straightforward. First, you import the module. Then you open your file, just like we did before. After that, you wrap that file in a CSV.reader object, and that's it. You're all set to just loop through the rows. Now here's the crucial part. What do you get back on each loop? The CSV reader does all of the hard work of parsing each line and hands you a neat Python list, where each column is an element in that list. So now you can access your data by its position, its index. Row 0 gets you the name. Row 2 gets you the status. Writing is just as clean. You create a CSV.writer object, and then you can use .rowwrite for a single row, like a header, or .writerRows to just dump a whole list of data all at once. The module takes care of all that tricky formatting with commas and quotes for you. It's fantastic.
So we've come a long, long way. The CSV reader works perfectly. It gets the job done, but, and this is a big but, just because something works doesn't mean it's good enough. We can do better. We can write code that isn't just functional, but is also clear, readable, and totally future-proof. This is the key question you have to ask yourself. When you come back to look at your code in 6 months, are you going to remember what row 2 is supposed to be? I know I wouldn't. And what happens if somebody adds a new column right in the middle of your CSV file? Your entire program breaks instantly. Relying on these magic numbers is just so fragile. So this is what our code looks like right now. It works, sure, but you basically have to keep a mental map of column numbers just to figure out what's going on. And now look at this. This is the professional upgrade. Instead of a CSV.reader, we use a CSV.dictReader. It's an absolute game changer. It automatically uses the first row as headers and then gives you back a dictionary for every other row. So now you access data by its name. Row.name is crystal clear. It's unambiguous. It's just so much better. And this isn't just about style. Using the dictReader and its partner, the dictWriter, makes your code self-documenting. It's way more robust because if somebody changes the column order, who cares? Your code doesn't break. It just looks for the name key wherever it is. This is how you write professional, maintainable code. All right, let's just recap the powerful toolkit that we've just put together. We've got the safety of with open, the simplicity of basic text files, the structure of the CSV module, and the professional power of the dictReader. That's a solid lineup. So here are the 4 rules that will guide you. First, always, always, always use with. Second, for simple little jobs, plain text files are your best friend. Third, the moment your data starts looking like a table, you reach for the CSV module. And fourth, to make your code robust and a pleasure to read, always prefer dictReader and dictWriter. You did it. You cured your program's amnesia. You've given it a long-term memory. You now have one of the most essential skills for building real-world